Hey, so I think the last training is not very good because limited data and uh, I tried for a few people and then um, the training result is not converged to certain point at the fast and actually it's disappointed. But I found a technique that actually I learned it on my training. Um, I think it's improved a lot. So, we'll use library named Albumentations. It's commonly used for augmentation. The library is basically bit easy to use, but I don't think it's that easy. But you can find many augmentation in it. Many of industries actually. It support many types such as classification, semantic segmentation, instance segmentation, object detection, and post-estimation. So the use case is very wide and it supports different domains from photo, medical image, satellite imagery, manufacturing, and others, and even QN. And it can be integrated with PyTorch, Keras, and others. Yep, and I support since it's free and open source. To install it, you need to install Albumentations. And yeah, here's the article fast as possible. I already done it on my drive. Let's see. Yeah, too much. I think it's my job, so sometimes I forget. Before I went to the augmentation, I need to inform that our image actually has border. Each of image has border. So I prefer to crop the border. So here is what it's like. Bit longer. Friendly reminder, I'm still stuck, but I think I should use my lanyard. It's Ghibli lanyard actually. Oh, very nice. Yeah, it's funny. Actually, I like this. Yeah. I cropped the image, yes. So it has no border. You don't see. The previous image has border. This is the result, which I produced previously. This is the trailing set, the original one. Yeah, the original has border for each image. And I tried to remove the border from the augmentation code. So basically it augment the training set, and then for each image and images for the training set, it produce a copy, several copy for each image, and then yeah, we apply some techniques such as rotation, and then other techniques such as RGB shift, zoom, or I'm not sure which one. Can use documentation. Alright, I'm a fan of Ghibli Studio, so I like to watch the anime. I'm not a big fan of anime, but Ghibli is our thing, I think. Where is it? The examples continue to turn up book. So actually, this one API reference, augmentation, transform. Actually, let's get to transform, but I think we can use transform. Blur limit. Yeah. It's actually Gaussian blur, I think. Blur, and then channel table. What is clay? Contrast limited analytic histogram equalization. So it's basically an advanced technique on augmentation. There's an area of it, I think. It'll be interesting to work in this area. You got PhD in computer vision and apply knowledge only for augmentation in your real life. It's cool. It's cool, I think. I mean, you don't do the machine learning or other stuffy things, but you only aim for augmentation in your real life. It's cool. Actually, you're productive, but yeah, you just draw into the machine learning, but it's cool. Transformers, yeah. I mean, you need the knowledge of, uh, advanced knowledge of machine learning too. I think to be a master of this, uh, it's actually not as easy as what you think. It's not like only use library. It's a bit complex. Flip, flip is actually a basic one. So you can flip the images horizontally or vertically. I forget it. To apply the transformation, actually you pass the probability, so the image can probably be augmented or not for each step. Yeah, sure, there's so many. Actually, you can choose on. This is glass blur. What is glass noise? Like, yeah. Actually, the light pass through glass is a bit blurred. Image compression. What? Oh, this is cool. You apply that your images is compressed into smaller file with lower quality. But how if or not you can apply over 100 quality? Yeah, here's my training code. To apply it, I use separated code for my training code because I don't want to mess up my training code. So basically, I don't like it. I like that my pre-processing is a separated code from my training code. So augmentation is basically pre-processing, but it is a long journey, so I prefer to spare it. Yeah. Okay. This is the best practice. It's tricky actually. So you cannot directly install augmentation in Google Colab, and you need to use it. The OpenCV version is a bit tricky. Actually, I had it a little bit. You should use the Hello OpenCV thing. And then what I use to generate the augmentation images is random crop, horizontal flip, vertical flip. I use both flip because yeah, actually it's a bit fun, but uh, yeah, if you flip the sky in the universe, it's made no sense. I think you just can see like this or like this or like this or whatever you want, or yeah, flip your head to see the sky. It doesn't matter. I think safe rotate. Yep, it's rotating the image, but uh, in safe manner, so it doesn't collide with it itself. So it's basically like this one, and then yeah, the shape is still right here. So the safe rotate basically apply images in tiles, and then I use RGB safe, but I don't think I should use RGB safe a lot since color gives information in uh, this kind of research, because different colors mean different uh, clumps. And I use random brightness contrast, but we will review it later. Maybe some of them is needed or not. It's kind of like a grid search, maybe. I don't think. Yeah, maybe. Oh, yeah, yeah. Yeah, it's cool. Actually, people adjust the hyperparameter to achieve the best uh, metrics, but how if machine learning is about choosing what is the best augmentation to achieve the best result? It's cool, I think. With the same data, with the same model, but different augmentation techniques. Yeah, here's the sample. I think I cropped the edges, but it's still appeared there, but actually it's not. Yeah, I augmented for 5 images, so actually this transform part is uh, run 5 times. Yeah, actually the output is 5 images, so uh, we have a list of images stacked 5 images. I made a separated folder so the images doesn't so the images don't you know, overwritten in one folder. Yeah, like this. I define the subset and the destination name just like this. So I change it file and like file crop, trend augmented. Yeah, just like that. And I uncomment it for the training set because yeah, keep in mind that we don't want to augment the validation and test set, since it will make the metrics a bit, you know, tricky to evaluate. Yeah, just like that. And with the augmentation code, and you can say that Mm, we have many training data, documented training data. So um, yeah, just like this. This is the original training data. Actually, I'm at uh, the next augmentation. Where is it? Just scrolling, scrolling, scrolling. Yeah. Oh, just wait, it's offline. H. Yep. Yep. There are more images. I think just like that. So, for each images, actually, we balance the class. Like previously, the class is imbalance, but uh, fewer the number of images, we made more augmentation. That's why I use if this one. So the amount is balanced. Yeah, just like this. I apply the augmentation. And the training is actually a bit improved. You can see that, yeah, it can train well, although it's a bit overfitted. So the validation accuracy is actually, yeah, you guess it, but by around, yeah, 60% it's right, but 40% it's wrong. Yeah, it can be improved. Maybe I set the validation set to few. Yeah, should we have better augmentation techniques? I don't know. We'll talk about the training later. Or the model. I think the model is too narrow. Yeah, it's very small, only 100 square, 100 by 100. It's very small. The original one is 700 by 700. Yeah, I think we need to improve the training then. Okay, see you next time. I want to watch Ghibli.